All right, so it's time for the next section. Hello, everyone. Can you hear me nice and clear? Perfect. So I'm going to put this on presentation mode. All right, so my name is PraveenRawat. I'm an Azure evangelist in the managed ISV space. The ISV space stands for independent software vendors. There are many independent software vendors across the US that I am working with. They are creating innovative cloud solutions and products. And the job of my team is to make sure that these products are successful on Azure. So we give technical guidance, etc. Go-to-market strategy. I'm also an Azure certified MCSD. So that's about me. We also have JimONeil, who's a senior architect in Blue Metal. He is a former Microsoft employee and a former Microsoft MVP. He has done the labs for this section. All right, so this module is about designing advanced applications on Azure. So these are the different kinds of applications that we are talking about. The reason why they're advanced applications is because they have needs that are beyond the typical web application or that typical API application. An example is asynchronous, loosely coupled applications that need a high amount of durability and reliability. They need to implement asynchronous patterns using messaging. That's an example. So, a very common example is the order processing application where you can submit an order, but let's say the receiver of that order is offline. In that case, you don't want to lose that order. That order has to be persisted somewhere. So the most common way to solve that problem is using messaging. So using queues and topics is a common way of solving that problem. You could say that why not just store those messages in a database, but we don't want to be tightly coupled to a database. We don't want that to become a bottleneck. So we're going to talk about implementation of these kinds of loosely coupled applications. That's the messaging options. We'll talk about creating long-running applications on Azure. So applications that run maybe on a schedule, they run for a long time, and they have a request. They're not your typical application that has a request and response period of maybe a minute, 2 minutes. A common example could be a billing application that has to run for a few hours every month. So that's a typical long-running application. We'll see how we can implement these kinds of applications on Azure. And then we have those big compute-intensive applications that cannot be satisfied with the typical CPU SKUs that we have, the typical memory and SSDs that are present in a typical CPU. We need high-performance compute. And we'll talk about GPUs. We'll talk about the kinds of technologies on Azure that can work as accelerators to provide compute-intensive applications. And finally, we also may have scenarios where you want to integrate some common services into some kind of an advanced application. So for example, we might need some machine learning or advanced analytics. There might be some kind of search that you want to implement as part of your application. So that's going to be the last section, integrating Azure Services. So let's jump into the Service Bus. So the Enterprise Service Bus is a very commonly used term. It's a very common technology. I'm sure many of you have worked with various enterprise service buses in your careers. The way that the enterprise service bus in Azure is different is that it's a pure platform as a service with no infrastructure management. So you're not managing any licenses. You're not managing any servers. It's a pure PaaS service. It also has capabilities. Well, you might be thinking it's a PaaS service. How do I work with the Azure Service Bus? So, well, we have SDKs. We have RESTful APIs that you can use to integrate and use the Azure Service Bus. And if you want to manage it, then we have the Azure portal. You can use the UI in the Azure portal, or you could use PowerShell. So you've got various options to manage that Service Bus as a platform service. It has relay capabilities, which means that it can be used to talk to on-premises systems. We'll talk more about the relay service within Azure, how you can have hybrid connections into an on-premise system without opening a firewall port, without using a VPN, and by just using an outbound connection, a secure outbound connection, a reverse proxy. The Service Bus also supports AMQP and common protocols such as HTTP. It also has a proprietary protocol called the Service Bus protocol. And finally, it also has an Event Hub, which is a cloud-scale telemetry ingress service, a service that is used to ingress data at scale. So we'll talk more. There's a slide dedicated just for the Event Hub. So let's talk about topics. The topic is topics. The Service Bus topic is just like your usual typical enterprise service bus topic. It's a one-to-many broadcasting scenario. You want to send one message and have this broadcasted out to multiple receivers. Let's take an example. A topic could be a billing service. So you could have multiple receivers who might be interested in subscribing to that billing topic, and basically, whenever there is a new bill, then they would receive that new message. We also have advanced capabilities such as the ability to filter messages. So a receiver does not need to get every single message that is coming on that topic. You can set criteria to filter and just get what you are interested in. For performance reasons, you can also receive a batch of messages, or you can also send a batch of messages to the topic. Now, these subtle features are important for the exam. For example, filtering messages, because many times when you have a scenario where filtering messages is important, then remember that Service Bus has this capability. So if you see an option on the exam, let's say one of the options is Azure Storage Queue, remember that Azure Storage Queue does not have the same enterprise messaging capabilities that we're talking about here. The Service Bus queue is that point-to-point communication. So one sender sends one message to a queue, and one receiver is going to receive that message and send back an acknowledgement that, yes, I have received the message. That message is then deleted from the queue. It's a one-to-one, point-to-point communication. The first in, first out order is guaranteed by the Service Bus queue. And just like a topic, the queue also supports batch receive and batch send. So we had talked about Event Hubs, which is the service within Service Bus that can be used to ingest messages at scale with high throughput and low latency. Now, a typical use case for this within an enterprise would be IoT data or enterprise logging. So that's a lot of telemetry that's coming in. Now, remember that an Event Hub is like a circular buffer. A message that goes inside the Event Hub is going to expire in 7 days. In that 7-day period, if you want to persist that message into a persistent store like a blob storage or maybe a SQL database, you can do so. If you want to use a service within Azure to do some analytics on that event, maybe do some real-time alerting, then you can do so. But at the end of 7 days, that message is going to expire. And the Event Hub does not have enterprise messaging features that are present in a service bus topic or queue. So for example, some more enterprise features in messaging would be the dead letter queue. If you have a message that goes into a queue and no one picks it up, after a point of time, it ends up in a dead letter queue. That is not something that you'll find in an Event Hub. The same thing applies for the time to live. You can define how long a message is going to live, TTL. That is not present in an Event Hub. The Event Hub is customized for high throughput, high scale data ingress. It's not a messaging solution. So exam tip. An Event Hub is created in the Service Bus namespace. Because the Event Hub sounds different from Service Bus, so it's common to kind of think it's a different service. But whenever you see an exam question saying, what is the first step that I have to perform before I can create my Event Hub, the answer is going to be, you have to make that Service Bus namespace. The Service Bus namespace is the container for all your Service Bus resources. So let's talk about what I was talking about earlier, the Service Bus relay, how we can establish connectivity in hybrid applications. So there are two main ways of doing this. The first one is Azure Relay. Azure Relay then consists of two different options that we'll talk about. One is called hybrid connections. The second one is called WCF Relay. Now, you might have heard about BizTalk services, BizTalk server on premises, and it's alive and kicking. BizTalk 2016 has been out for a while, and it's going to stay on premises, but many of BizTalk's services features have moved into Azure in the form of Azure Relay for hybrid connectivity and logic apps for creating workflows inside Azure. So you won't find a BizTalk service within Azure, but you'll see a combination of different services. I see a question?
So recently, microservices released March 2017. Microservices moved away or moved off of WCF related website.
Okay. Yeah, the WCF Relay is also part of the legacy offering within this Azure Relay. So let me just go into the differences between the two. WCF Relay is for supporting the old legacy workloads. It is tied to the WCF programming model and tied to .NET Framework only. The hybrid connection, on the other hand, supports .NET Core, is cross-platform. It can be used to connect to any static TCP port that you have on premises, not just WCF. That is the newer relay service inside Azure Relay. In fact, let me show you an architecture diagram. So here on the left-hand side, we have Azure. So we have web apps and we have mobile services. On the right-hand side, you can see you can download and install a hybrid connection manager inside an on-premises network. This hybrid connection manager can be installed on the on-premise resource that you want to expose to the service bus, or it can also be installed on a VM that has a connection to the resource that you want to kind of connect to. Now, like I had said, the hybrid connection can talk to any static TCP port. That could be a MySQL database, it could be a SQL Server database, it could be a RESTful API, any kind of API, etc. The way that it communicates back out into the service bus is, like I said, a reverse proxy method. So there is no inbound connection, there's only an outbound connection. It is pulling on a service bus queue, and the message inside the service bus queue is an encrypted message. It's a secure message. Only the hybrid connection manager has the private key to pull that down and decrypt that query into what it's supposed to be. Then it will connect to the database, execute the query, and send back the data, again through the reverse proxy. That's how it works. And like I said, the WCF relay is for legacy workloads, just for WCF and .NET framework. The other way of connecting your Azure web apps and app services to on-premises is by establishing VNet integration, the virtual network integration. So through VNet integration, it gives your multi-tenant app services web app access to an Azure virtual network. Let me show you a diagram of how this is done. So in your infrastructure session, you might have seen the differences between a point-to-site and a site-to-site VPN. So what happens here is, if your Azure web app, your multi-tenant app service, wants to connect in to on-premises, using VNet integration, it can connect to an Azure virtual network that you can see on the right-hand side. And this needs two things to be done. And this is a common exam question. What does an Azure web app need to establish VNet integration? The answer would be the VNet on Azure needs to have a dynamic gateway enabled. And secondly, it needs to have point-to-site VPN enabled. So you can see here the web app is connecting using point-to-site to the Azure VNet. And because of that, it now has access to all the resources that the Azure VNet has access to, including the resources which are on-premises, which it has access to because you can see here it has a connection to on-premises using a site-to-site VPN. Now, if you had an Azure web app and you had subscribed to the premium layer, the premium tier of an Azure App Service, well, in that case, you have an app service environment, which is a dedicated single-tenant infrastructure that you have deployed into your own virtual network. You might want to do that if you want to control, you want to control your IP range, you want to control access to your public endpoints. You want all that infrastructure. So in that situation, you might have what you see at the very bottom, the app service environment, which then can just directly be deployed into your virtual network. If that's the case, then you can directly have a site-to-site VPN from that app service environment directly into on-premises. Any questions? All right. So here we have a question. Your application needs a brokered messaging channel to an on-premises line of business application that offers a WCF endpoint. You need to implement connectivity without changing on-premises firewall rules. Implementation needs to have a lower cost compared to other options. Choose an implementation below. Does anyone want to answer the question? I can see a hand. WCF relay, yeah. Now, as architects, you might lean towards hybrid connection because obviously that's the forward-looking, service which can connect not only to WCF but also to a RESTful API or a database, etc. But this question is particularly asking just about WCF endpoints, and it says we want to have a lower cost. So WCF relay is the most cost-efficient option here. And of course, down the line, if you want to also connect to other services, resources, then you can replace that with a hybrid connection. ExpressRoute, obviously, like you know now, is that dedicated WAN extension, that private pipe between Azure and on-premises, but it's not cheap. And the question has asked for low cost. And site-to-site VPN, again, it requires some firewall manipulations here and there at times. So if you look at the question, all the criteria are satisfied by WCF relay. That's the answer. So let's look at some of the service bus tiers that we have within the service bus. Note, and this is important for the exam, note that in the basic tier, we have 100 brokered connections. In the standard tier, we have 1,000 brokered connections. And in the premium tier, we can have thousands per messaging unit, and we can keep on adding more and more units. A brokered connection is any device, any application that can connect to your service bus, can send messages, receive messages, etc. So think about those limits when the questions come. And in fact, and yeah, by the way, one more option to note here is that if you look at the last property, which is resource isolation, if you have really advanced compliance needs, or you really want to have a dedicated instance of your service bus, maybe you have a customer that is so large that you want to have really predictable performance metrics for that customer, and you are hesitant in choosing the multi-tenant service, even though the SLAs are pretty strong there, then you might want to go for the premium tier, which gives you that resource isolation and predictable performance metrics. So question number 2, you need to process IoT data from approximately 700 devices. Data is filtered and moved into blob storage. Archival of raw ingress data is required for 1 week, 7 days. Choose an implementation below. Any answers here? It is Event Hub, but which SKU, which tier? Standard, yep, because it said 700 devices, and the basic tier only supports 100. The standard tier supports 1,000, so that's below our limit. Perfect. I won't dwell upon Azure Storage because we have covered this already. I just wanted to point out that Azure Storage has queues as well. And like I had mentioned before, if you have a scenario where you just need lightweight messaging, nothing else, then this might be a good fit. But if you're looking for advanced messaging capabilities, like you want to be able to classify your messages, you want to be able to prioritize your messages, you want to filter messages, well, in that case, you won't be able to do so using Azure Storage Queues. You would then want to use Azure Service Bus queues or Azure Service Bus topics. So if you see questions like that, then you know which one to choose. So let's move into implementation of background processing within Azure. So Azure Web Jobs provides an easy way to run background processes in Azure. These can be background programs. These could be exe files, Java jar files, PowerShell files, Python scripts, anything you name it. And these run within Azure Web Apps as web jobs. And they can run inside a context of an app service, an API app, or a mobile app. They can be scheduled to run on a schedule. They can be continuous, or they can be triggered on demand. A continuous web job, think of it like a Windows service that's always running. That's like your continuous web job. The scheduled web job actually uses the Azure Scheduler SDK, and Azure Scheduler is a service that we will be covering in a subsequent slide. The web job SDK is pretty easy to use. You can see an example here. So here, all I'm doing in this code snippet is I have a function called Service Bus Queue. To Service Bus Queue, I'm saying I want to just take a message which is arriving in the start queue name queue, and I want to just add a simple message and shift that into a service bus. So all I'm doing is triggers. I'm not doing all the clunky, you can say, plumbing of setting up my service bus and all that. All I'm doing is defining my triggers. I've got the service bus trigger that tells my application, my web job, that, hey, the moment there is a new message here inside this queue, pick it up. And you'll actually see this function get into debug mode. If you put a breakpoint, the moment you put a message, you'll see this being hit without even initializing any of that stuff. And then you can move that. What I'm doing here, I'm adding a small message and moving that into the service bus. So look at these triggers and how they're used. Service bus trigger, we also have triggers for Event Hub and other services. Storage. So we have multiple triggers that you should look at for the examination. So you must have heard about Azure Functions, the whole Uberization of compute, the serverless compute story in Azure and other clouds. So Azure Functions is that serverless, highly scalable architecture. It's you can say that the next evolution of web jobs. So web jobs, again, is a platform as a service. It's running as a web job, but it's still running as a PaaS service. The basic difference between IaaS, PaaS, and serverless, you can say, in PaaS, you're abstracted away from the infrastructure. So you're saving costs when it comes to infrastructure management, but you're still paying for the underlying infrastructure that is running, and you're paying for that continuously. The whole pricing model in serverless compute is different. So now you only pay for the amount of time that your Azure function is executing. You don't care about how many VMs are executing in the back, how you scaled up or how you scaled down. So it's the next generation of compute on Azure. You can write Azure Functions in Node, in JavaScript, in C#, in Python, PHP, and you have multiple continuous integration options such as Bitbucket and GitHub, etc. This is very suitable for trigger-based programming. So a trigger happens. So there is a new, let's say I have a blob storage account, which has PDF files. I have an Azure function that does some kind of PDF indexing. The moment there is a trigger, a new PDF file has been uploaded to that container, that blob storage. That function will execute, do something. It should do that inside 5 minutes, because we have a 5-minute limit on Azure Functions. This is for really small snippets of functions, and then give back an output. Now, of course, if you want to implement a more long-running process inside Azure, then you don't want to implement that whole workflow inside Azure Functions because you have a 5-minute limit. You want to maybe use logic apps or a web job to do the long-term processing, and just use Azure Function as a component for those small tasks. And of course, locally, the Web Jobs SDK can be downloaded and used in Visual Studio for your dev and test. All right, so question. You're trying to implement a background process to send emails on a scheduled interval. Which Azure function triggers would be suitable? Any guesses? OK. All right, so this was a bit of a trick question that I put in. So I had told you that Azure functions generally execute when a trigger has happened. In this situation, it says scheduled interval. So this is actually a scenario where we want to execute this on a scheduled interval. So the right answer is timer and HTTP. That is how you would implement this Azure function, because it's slightly different from the typical trigger-based Azure function. A timer is basically setting a schedule. At this time, execute my Azure function, and just basically hit my endpoint. All right, so let's move into the creation of long-running applications inside Azure. Here we'll cover Azure Scheduler and Azure Batch. So Azure Scheduler is a platform as a service for scheduling reliable actions on a recurrent, or you can say a simple or complex schedule. So when I say a complex schedule, I'm saying a schedule something like, okay, I want to execute this action on the 7th day of every month, right? The 7th day of every month could be different for every month, but that's how you could define a complex schedule. So a scheduler can be used to do all these kinds of scheduling. It also supports Service Bus Relay, and it also, in fact, supports ExpressRoute for connecting into an on-premises network and also managing and hitting resources inside an on-premises network. This is a platform as a service, so it has high availability built in. It also has failover built in. So even if there is a disaster, there is failover built into this particular service. And you can also have a configurable retry policy. And on the right-hand side, I'm showing what a typical retry policy looks like when you define that in JSON. So here you can see my retry policy has a retry count of 5. So it's going to retry 5 times. And the retry interval is PT1H, which means every hour, every 1 hour. This is a common question in exams. If the requirement was every minute, it would have been PT1M. M stands for minute. 5 minutes, 5M. We also have an error action defined here. So for example, if there is an error that I have received back when I try to invoke some kind of a service that was supposed to run, then it is going to invoke this URI, the contoso/error. Now note that this URI, my error action URI, could be in a different region. It could be in a different region as the primary service. So if I'm having trouble with one region, if I'm having trouble with that service, I could even use the error action to kind of move into a different region. Another very popular service is the Azure Batch service within Azure. This is a platform service for developers to provide job scheduling and VM management as a service. And this is one of the high-performance compute services on Azure. So, if you have a requirement, maybe you have some kind of a media encoding service or a massive parallel computation job that has to run some kind of deep learning scenario, and you need to spin up 10,000 cores, maybe just for 10 minutes and perform the job and come back, well, you can use Azure Batch for that. Both Windows as well as Linux workloads are supported. The basic hierarchy of an Azure Batch account is kind of important. So the top level hierarchy is the batch account. Within the batch account, here you see a pool, a batch pool. Within that, you have jobs, which are typical jobs that you define for your on-premise workloads as well. And then within that, you have your tasks. The task is a unit of execution. Anything that can execute from a command line, like an exe or a bat file, a PowerShell command, can execute in Azure Batch. One of the nice things that my partners like about Azure Batch is you don't have to refactor your applications and, we need stateless applications. Just take your existing stuff and just dump it into Azure Batch and scale it up and down. So it's a nice service for lift and shift kind of scenarios. Now, the batch service is responsible for taking the tasks that you have submitted and assigning them to VMs. If your VMs, let's say they fail, something happens, it is responsible for retrying those tasks on new VMs or new VMs that get spinned up. You might have heard during the build conference that the low priority VMs were introduced as part of Azure Batch service. You may have heard about AWS's spot instances, where if you have surplus capacity, then you can get, you can bid a certain price for VMs, and you can get VMs that are very low cost. So low priority VMs are that kind of service within Azure. Linux VMs are available at a 80% discount, and Windows VMs are also available at a discount. So this is using surplus capacity, but remember, these can be yanked out. So if Azure decides to yank out this capacity, then the batch service will be responsible for then retrying your fail task on a new VM once it's available. So here is a basic architecture diagram of the Azure Batch service. Like I said, this is a platform as a service, not an infrastructure service. You can see that it's built on top of IaaS virtual machines. While provisioning the Azure Batch service, you can decide which kind of Azure VMs you want to work with. And the way that you interface and work with Azure Batch is not through a really sophisticated UI. We have open source UIs out there, but mostly this is for your DevOps staff to work with. The work that you do with Azure Batch, the way you manage these nodes, is mostly using PowerShell and scripting. And this, from an exam perspective, is a main difference between Azure Batch and HPC Pack. That is one of the main differences that you'll see on the exam. So if you're asking for that management node, that high-end, sophisticated kind of user interface and portal, that's the HPC Pack. That's not Azure Batch. Well, I just gave you the answer to the next question. Your company needs to run large-scale computational workloads. The compute cluster should be able to scale up and down on demand. You're looking for a cost-effective option which can be managed via command line scripting. Choose the option, you guessed it, Azure Batch. Many people also use web jobs for implementing kind of parallel processing, but there is a certain, just so much you can do in a web job. You really want to go with the HPC service for massive parallel computation. So exam tip, you do not need to create a virtual network or a scheduler when you are creating an Azure Batch service. And the reason being, this is a platform as a service. You don't have to create these individual components. Those are going to be created for you behind the scenes. All right, so let's look into some of the compute-intensive applications. And many people think that, compute-intensive HPC applications, right? The compute use cases that we have had over the years. You've seen a lot of work being done in media encoding, rendering, image analysis, OCR. That's a very typical plain vanilla use case for big compute. Remember, big compute is different from big data, so don't confuse big data and big compute. Big data is large amounts of data, being able to query large amounts of data. Relevant services on Azure for big data would be Hadoop as a service, which is HD Insight, or Spark as a service. That is different from big compute. In big compute, we're talking more about lots of CPU, GPU, high memory, high CPU intensive tasks that have to run in parallel. So there is a differentiation there between the two different kinds. Go ahead. No, it's the same. Big compute is HPC. Right. So we have seen, Monte Carlo simulations, stress analysis, all these use cases, and more recently with the announcements of new GPUs and SKUs. Now, we've gone into AI, deep learning, massive parallel computation, risk analysis. So it's not limited to just images and transcoding and those use cases anymore. So just a bit on the big compute evolution from on-premises into Azure. Initially, we had the HPC pack on-premises, which was a pure HPC pack cluster on-premises. which had the management node, the head nodes, all of that. Then we had a HPC pack hybrid offering that was bursting out into the cloud. So you have the management nodes inside on-premises networks, but you can burst out into Azure. Then we kind of also brought in the feature where now you can also have management nodes and head nodes inside Azure. That's HPC pack IaaS. And finally, you also have the Azure Batch platform as a service, which is the scripted way of managing HPC clusters on Azure. But this evolution means we're adding services. It does not mean that Azure Batch is better than HPC pack hybrid or vice versa. Each of these services has its pros and cons and is relevant depending on the kind of requirement that you have. So high performance computing on Azure. So our customers are looking for, they're looking for a no compromise HPC platform. They're looking for no compromises. What I see a lot is our customers that are benchmarking us on Azure, they're already running their HPC workloads on premises. So they're basically getting bare metal performance. And they're benchmarking Azure against bare metal machine performance with physical cores. And that is the level that we have to reach to. So that is our goal, to kind of compete with that kind of a benchmark. So we have GPUs and Mellanox InfiniBand RDMA for that purpose, to kind of compete with that kind of benchmarking performance that we have to be put up against. So by using Mellanox's InfiniBand, I see a question? You're yawning? So by the way, Mellanox InfiniBand is only available within Azure. And this can be used to provide microsecond low latency between two servers within a single network. So we're not talking about milliseconds. We're talking about microsecond latency between servers on a network. And then we also have RDMA, which stands for direct memory access, remote direct memory access, which in conjunction with Mellanox InfiniBand and our GPUs that have been introduced in partnership with NVIDIA's processors, it can give you microsecond level latency. So very quickly, let's touch upon the new SKUs that we have on Azure. Some of these have been announced in the Build conference. So we already have the A series. So make sure that you understand the entire SKU of the A series. The higher end A series are the ones that have InfiniBand and RDMA enabled. Then we also have different SKUs for different kinds of requirements. So for example, if your requirement is large SSDs, then the L series that you see in the lower right-hand side might be the SKU that is applicable to your requirement. We have also, not recently, but over the last year, we introduced the NC and the NV series in partnership with NVIDIA. These have the Tesla K80 and the M60 Tesla cards for GPU level performance. During the Build conference, we also announced the ND SKU, which is for deep learning, and the NC-V2, which is customized, which NVIDIA has customized for massive parallel computation. And we also introduced the DV3 and EV3 SKUs. These are generational SKUs that also have a Windows Server 2016 feature called nested virtualization. So you can have a VM inside a VM inside a VM inside a VM, just like Inception. And the kind of use case you can satisfy with that is if you have bought a GPU that is pretty expensive, maybe it's costing you 90 cents a minute or hour, you can implement nested virtualization to make sure that you don't waste any capacity. You use that VM to the maximum you can by subdividing it into further Windows or Linux VMs. So exam tip, if your HPC compute cluster requires the management head node and the choices are batch or HPC pack, then choose HPC pack, because Azure Batch is a command line driven scripting way of running HPC. All right. So now let's talk about integrating Azure services within these advanced applications. And you can do so by using NuGet packages, SDKs, or RESTful APIs. But let's touch upon some of the key services out there that you might want to use for designing that advanced application. First of all, Azure Search, a fully managed search solution that enables you to create a search experience within Azure without building that full text from scratch. Azure Search, although it's similar to SharePoint Fast Search, it is actually not SharePoint Fast at all. It's based on the Lucene, the Elasticsearch engine, the open source Lucene engine. And if you have ever deployed a Lucene cluster, then you'll know that deploying an IaaS infrastructure cluster is no trivial task. So when you spin up an Azure Search service, which is a platform service, it deploys the Lucene cluster for you. And then there are many capabilities that you can use out of the box by using the SDKs and the APIs. Let's go into a few of those use cases. Some use cases may be an e-commerce site. You're searching for products, and you want that search experience to be more like a search engine, more relevant. You might have a news feed inside your application. Imagine having a news feed, and this has happened to me on Bing, unfortunately, where I search for something and I get results from 2010. That's so annoying, right? If you get old results back. So you want newer articles which are more relevant to come up in your search. You want the engine to know that. Geospatial search, just imagine Yelp without geospatial search. Those search results have to be relevant to the location where you are searching from. And of course, a very common use case, unstructured content, where you maybe have a document repository of PDF files and images and different kinds of documents, and you want to implement some kind of a document management search experience. And you can do so by using the various indexers that are built into Azure Search. So we have indexers for blob storage, for SQL databases, etc. And then, of course, some features that we just take for granted, but the engine should know about it. For example, term boosting. If someone searches your application for a quiet, clean hotel, depending on your business logic, you might want to put more emphasis on clean than quiet. Well, depends on your business. You might want to put more emphasis on quiet instead of clean. But that kind of a scenario is term boosting. And then, of course, synonyms. And synonyms was actually introduced just a few months ago. But if I'm searching for hotel and there are lots of motels listed, I don't want to eliminate those from my search results. So I want to be able to incorporate similar sounding synonyms inside my search experience. So that's Azure Search for you. The other service that's commonly used is media services. So when you look at media services, live on-demand streaming, being able to distribute content using a CDN network, the edge network that we have. Like I said, we are in 38, well, I don't know if I said that, but we are in 38 regions around the world, more than AWS and Google combined. And the CDN network can be used to distribute your content to customers, so you can get closer and closer to your customers and have that low latency experience for your content. You could have a digital marketing platform, so management tools. Now, this is something for the corporate environment, for your corporation and for your partners. So it means security, it means role-based access. And I have a question coming up that is based on that. But what I'm saying is, media services is kind of easy when it's on the public domain, like Facebook and Google Hangouts, right? But when you think about a corporate setting where you want to distribute to different channels with role-based access and security, that's where media services comes into the picture. Like I said, you've got live event streaming, CDN capability, studio-grade encoding, content protection, encryption, and you can distribute content across multiple channels and devices. All right, so question time. Your company uses Azure Media Services to supply advertising media to your partners. Multiple channels are configured within a single instance of media services. You need to enforce a rule that only content that contains a signed security token be uploaded. If it does not have a signed security token, it should be blocked. How do you enforce this rule? Network security group, ingest restriction, access control list, or media services authorization policy to token. Now, I guess any guess would do because I haven't explained this yet, but go ahead. That's right. So the network security group deals with, for security between subnets and virtual networks, so that's out of question. Media services is a platform service. It doesn't have VNets and subnets. ACL, access control list, is again out of question. This is not a VM endpoint or a VM port we're talking about. This is a platform service. The ingest restriction would have been the answer if the question was something like, hey, I want to only restrict uploads, ingest of data from a particular IP range or a particular location or just one IP. If that was the question, then ingest restriction would have been the right answer. But in this case, this is about a single, assigned security token. So the answer is you want to override the default authorization policy in Azure Media Services. The default is called open, and you want to set that to token so that only signed tokens. So any partner will have to get a signed token and then upload their content. All right, so how am I doing on time? Anyone? All right, 5 minutes. So this slide will take me exactly 1.5 weeks to complete. Do you have that much time here? Okay. We have data camps that go through every single piece of the data offering that we have on Azure. Obviously, I'll just scratch the surface here. But basically, if you look at a typical data flow inside not just Azure, but anywhere, you talk about event production. Lots of telemetry is being generated. This could be devices, this could be applications, this could be services that are generating this kind of data. Then you have the collection of that data. You have different ingestion points of that data. We had touched upon Event Hubs as that ingress service for for large amounts of data, large volumes. We also have the IoT Hub that you see here in the very center. The main difference between the IoT Hub and the Event Hub is the IoT Hub is bidirectional in nature. It can communicate back down to the IoT device and tell it, restart, update, run a Docker container, things like that. It can actually ship a Docker container into an edge device and run some compute on that edge device. So IoT Hub is bidirectional in nature. Then if we move on, we can also do real-time analytics on that data. So for example, you could be getting events of data, and I have a partner in the West Coast that is actually doing this for methane gas sensors. They're getting a lot of telemetry for water pressure. Not water, but methane gas pressure for the valves across the field. And so what they're doing is they're using the SQL kind of query that Stream Analytics provides to query that stream of data. And then they're using windowing functions to keep on querying that data. When I say windowing function, I'm saying I want to check let's say, the gas pressure of this valve in the last 5 minutes, and I want to make this check every 5 seconds. That's a typical windowing function. So if you go deeper into stream analytics, you'll see the different kinds of windowing functions that you can implement. But then the moment they see that there is some kind of an anomaly, something seems to be wrong, they can shut down that gas valve because they feel it might be leaking, and they can alert a technician, go and check on that gas valve. So then, of course, we can also do machine learning. There's so many different kinds of data science experiments that we can do on historical data sets as well as current data sets. Question? Again, you're yawning? All right. So machine learning, you might have heard about the different kinds of typical data science problems that we try to solve. Let me actually skip over to the next slide to show you some of them. So for example, you might think that, hey, you know what, I could do some regression analysis on my data, train my current data sets to do some regression analysis. For example, Boeing is using regression analysis in Azure to say, what is the remaining useful life, or RUL, of a Boeing engine? If the RUL score is low, then send a technician, or if it's really something that happened very, very quickly, just ground the flight and cancel the flight. We could be doing anomaly detection that you can see there. So for example, if you are in some kind of a financial application and you're doing some kind of audit, and you're looking at historical audit data, and you see the flow of money from a balance sheet item to a balance sheet item that you haven't seen before, that's an anomaly. Things like that can be caught by developing these kinds of models on machine learning. And one more thing that is really, really useful in machine learning that I want to touch upon is the fact that it is not just about playing around with data models, it's also about commercializing these models. What we see is many of the data analytics projects fail because people are never able to commercialize the models that they build. It becomes a big experiment, and that's about it. When you want to commercialize that, you want a quick way to take that model, expose that out as an API. And we have a service in Azure called API Management, which is exposed behind the scenes in the Machine Learning Studio. So once your model is ready and tested, you can click a button and say, generate a RESTful API. The RESTful API gets generated with test data and with documentation. Very similar to many of the API proxy tools out there. So you can do that, and you can productize your models right off the bat. So that's machine learning. And of course, on the very right-hand side, if you want to do retrospective kind of analytics where you look at a dashboard and then you want to make decisions, then you can use Power BI to create dashboards and then make decisions retroactively instead of making them proactively like you would have done if you were doing machine learning. So the labs are available on the lab site, and Mr. Jim has been kind enough to create those labs. These are relevant to some of the Azure services that we have touched upon. Any other questions before I wrap up? I think we're good. Thank you.